In today's video, we're quickly going to learn how to convert any object that you have or any scene that you have into pixel art right within Blender. It's going to be really fast and simple, and it'll mainly use the compositor. So with that, let's actually begin the tutorial. Now, of course, you could use any object from even previous videos that you've created, but for today, I'll quickly create another object to convert into pixel art. If you want to skip directly to how to convert to pixel art, you can use the chapters present at the bottom of the video. So for now, I'll just add in a star. So I'll press Shift A and search for a mesh circle. Then before I do anything, I'll expand it and change this down to something like 10, which is twice the number of arms that I want for the star. Then I'll press Tab to go into edit mode, and I'll go to select and choose checker deselect to just select 5 of them. Then I'll press S and scale this down until I get the star shape that I want. Then I'll press A to select everything, and I'll switch to edge select mode by pressing 2 or this button up here. Then I'll press E to extrude, and I'll press enter followed by S, and then just a little bit till I get a nice border for my star. Once I'm happy with the border, I'll again select all of the inner edges by pressing Shift Alt and then selecting an edge, which will select the entire inner ring. Then I'll press F to fill it in and create a face for the center. Now I want this face to be separate from the rest of the geometry, so I'll press P for separation, and I'll separate by selection. Now I have the outer star and the inner star. With the outer star selected, I'll go to the modifiers and I'll add in a solidify modifier, and to make sure that it doesn't increase in thickness only on one side, I'll change the offset down to 0, and I'll maybe give it a thickness of 0.18. Now I can go ahead and apply this modifier so that when I actually go into edit mode, I have all of these new edges to work with. So I'll select all of these outermost edges that have just been created from the solidify modifier, and then I'll press Shift D to duplicate them. Then I'll press S to just scale them up by a little bit, followed by E to extrude, and then again I'll press enter, S, and I'll scale up the newly created edges as well. Now that I have these faces created, I'll again select all of them by going to face select mode and just selecting these 5 faces that were just created, and then pressing P selection so that I have these as another object as well. Then I can go back to the modifier properties and add in a solidify modifier for just these 5, and just like last time, I'll change the offset to 0 and increase the thickness to this time maybe 0.1. Now these are like the shining light rays from the star, which again, based on your preference, you could have midway like that, or you could have them just outside the arms like this, which is how I'm going to keep mine. Now I want all of these to be parented to this central star, so I'll just shift select these and then shift select the central star at the end and press Ctrl P and choose set parent to object. So now I can take this central star and press RX90 to rotate it on the x-axis by 90 degrees. Then I'll go ahead and give these their own materials. So I'll go to the material properties, press this plus button to add in a new material, and this one I'm going to call as base star, which is going to be fairly bright. So I'll make it all the way to the value of 1, and I'll make it a yellowish color because stars are generally yellow. Then I'll go to my outer ring, I'll add in a new material, or I'll select maybe the default material itself, and I'll keep this at a complete white, and I'll change this to star outline, and I'll leave it just like that. Then I'll select these sparkles, I'll press new, and I'll call this sparkles, and this one I'll give it the same yellow color, but I want it to be completely bright and independent of the light source. I want it to be very, very bright. So instead of having just a value of 1, I'll increase the value to something like 5, and then when I switch over to my viewport shading of rendered, I should be able to see what I have. So this looks good enough, but the main idea for getting really good pixel art is having nice shadows. So for those shadows, I'll have to place the light appropriately. So let's select the light, press Alt G to clear its location, followed by GX to move it on the X axis. Then I'll press GY to bring it front, and that should create the nice shadows. Now I'll press GZ to just lift it up a bit, and I think this position of the shadows is better. And of course, you can choose exactly where you want to place it and how much shadow you desire. Now if I look closely, there's a little bit of light leaking happening over there. If you don't want these sort of artifacts to be present, you can expand shadow and choose contact shadows, and that way you can see that the shadows are actually proper and there is no more light leaking. Apart from that, if you want softer shadows, you can increase the radius a bit, but I'm going to keep the radius at maybe 0.25 to have not too sharp nor too soft shadows, just like this. Once that's done, we can start off with the animation. So let's select this particular circle, expand our timeline, and then go to our output settings. In our output properties, we can change the frame rate to a much lower frame rate, and one of the standard frame rates for pixel art is 12 frames per second. So we'll go to custom and we'll change the FPS to 12 so that we render out only 12 frames per second. Now we'll change the end frame to maybe something like 60 so that we get a 2-second long animation, and then we'll go to the object properties right over here. Then on frame 0, we'll hover over the Z rotation and tap I, or we'll go down to this little dot and select it to add in a keyframe only for the Z rotation and not for the X and Y. Then we'll go to frame 60, which is our last frame and we'll change this Z rotation to something like 180, and then we'll press this little diamond button now, which will add in another keyframe. So now when you play the animation, this is what you have, and I think that looks good enough. The next thing that we have to do is actually place our camera. So let's select the camera, press Alt G to clear location, Alt R to clear rotation, followed by RX90 to rotate it on the x-axis by 90 degrees again. Then we'll press 0 on our numpad to go into the camera view, and we'll press GY to just bring it back until we have the entire star within our view. Now that we have the entire star within our view, we'll have to deal with the background so that we don't get these sort of edges where they're almost the same color. Now, of course, in most scenarios, you're going to be rendering this out with a transparent film itself. But if you are doing so, make sure that your output properties has a file format of PNG with the color as RGBA, which will export out a sequence of images. But in case you do want a video format itself, you can choose a file format of FFmpeg video with a container of QuickTime and the video codec set to QT animation. If you have the container at QuickTime and the video codec as QT animation, you should be able to select RGBA as your color profile, and that way you'll be able to render out a video with a transparent background. There are other containers and video codec pairs that will work to create transparent backgrounds, but this is the one that I generally use. However, for this video, I'm actually going to keep the background as a solid background with a value of a complete black so that I can actually render it out and use a Luma key in whichever video editing software that I'm using later on to remove the background. So for that, I'll bring my cursor to the junction of these two windows, click and drag to create a new window and change it from the 3D viewport to the shader editor. Then I'll switch from object to world, and I'll simply use a similar technique that I've used in multiple videos before, which is searching for a mixed shader and plugging that in right here and duplicating this background node, changing this to a complete black, and using a light path node to determine which background is used for lighting the scene and which one is used for the camera. So I'll use this is camera array as the factor and plug this into the second shader. Now this doesn't have to be black. I could change it to green as well so that I can use maybe a chroma key and green screen out the back. But for the purpose of this tutorial, I'll keep it as a complete black itself. Now to get to the actual pixel art portion of this video, we're going to switch over from the shader editor to the compositor and use Blender's real-time compositor to create the pixelation effect. For that, I'll switch on compositing in my viewport shading options by choosing camera so that we can actually see the composited effects. Then I'll check use nodes and I'll shift this render layers to the side and then change the properties over here. So I'll press Shift A and search for a scale node, which will allow me to change the size of the image. So I can reduce it down like that or increase it up like that as well. Now when I scale this down, remember the number of pixels are also decreasing. So when I scale it up, I should have a pixelized version. However, if I'm doing this, Blender does not actually store in the fact that it was scaled down, and it just undoes what it just did. So what you can do is press Shift A and search for a pixelate node, and this will store the pixel values and will prevent Blender from creating new pixels while it's being scaled up once again. So now if I scale it down by something like 0.2, I'd have to scale it up by the reciprocal of this, which would be 5 units, and that will keep the same aspect ratio but cause it to be pixelated. Now to control this easier, we can go ahead and just use a single value. So I'll press Shift A and search for a value node, and again we saw that this has to be the reciprocal of this, so I'll press Shift A and search for a math node and set it to divide. Now I'll change the first socket to a value of 1 so that if I plug this into the second value, the output will always be the reciprocal of this particular value. So now I can take this and plug it into both the X and the Y of this scale node, and I'll plug the original value into both the X and the Y of the second scale node. So now using this single value, I can increase the amount of pixelation or decrease it. And that's actually all there is to create really cool pixel art within Blender. If you're happy with the way everything looks, all you have to do is press Render Animation. Let's say you had an object present in a different blend file that you want to use over here. All you can do is go to that blend file and press Ctrl C with that object selected, come to this blend file and press Ctrl V to paste it. Now it gets pasted with all of its attributes from the previous blend file. So let's go to the keyframes, press A, X and delete all of the keyframes, and then just place it to whatever you feel like in your particular video in this case. Now, if you want to see how I created this particular yin yang animation, you can actually check out this video over here, or you can check out this other video that will be present in a few seconds, linked in the top right corner, and both of them will be linked in the description below. One of them uses modeling and the other one uses a nice form of mathematical shader editor techniques that allows you to create a procedural yin yang material. Now you can go ahead and change all of the world settings and things like that to match your particular scene, and you can maybe add in keyframes for the animation according to whatever you want. And once you're happy with all of that, you can go ahead and render out these animations as well. I hope this was a short and fun one for all of you, and the technique will be useful to create stylistic renders or maybe certain areas in your scene to give your scene some visual contrast. If you liked this video, do check out other videos on my channel because I post videos every single day and I'm sure there's something or the other just waiting for you to discover it. And truthfully, watching multiple videos on my channel will actually help the algorithm boost my videos to a larger audience. So until the next video comes out tomorrow, thank you so much for watching, keep creating, and don't forget to stay creative.